So if we use the table method on this one, I should read this, right? I forgot to read it. An airplane travels 240 miles in 2 hours with the wind, sorry. The return trip against the wind takes 3 hours. What is the wind speed and the speed of the airplane in still air? And again, I got to think about this a little bit because I'm not used to the table. But, well, here's what I do know, right? We got with the wind. That's the first set that they gave us. So it's 240 miles. That's distance. So you can put 240 in there, and then the time was 2 hours. Now the rate on this, whether you use the D equals RT, or if you manipulate that, just like we would have in 1.9, and said that the rate equals the distance divided by the time, I would probably do that first, because then I know that the rate is going to be 240 divided by 2, which is 120. That's in miles per hour, right? Now that was with the wind. So, against the wind though, right? It says it's 3 hours. Now it's the same trip, so we know it's 240 miles. That's fine. It's just the time is going to be 3 hours on this one. So the rate is going to be 240 over 3, which is now 80. Now again, if I were doing this problem, I'd say, well, what's the number right in between 80 and 120? And that's 100. And that means they're 20 apart from 100, both 120 and 80, so I would know the speed of the plane and the wind speed. But let's say that we didn't realize that right now, right? So I just writing the equations on this one. We do need to define the variables, right? I'm going to use x and y, even though you could use w and a, w for wind speed and a for airplane speed. It doesn't matter. But for me, x is going to be the airplane speed. And then y, airplane, I think I spelled that right. Again, this is speed. And if you're wondering how we know that it's speed, it's because that's the two variables with your systems need to represent whatever it is that you're solving for, right? Because once you say x equals something, then it should solve at least one of the two things that we're looking for. So airplane speed, y is going to be my wind speed. Now speed is a rate comparing distance and time. And so when I go now to write my equations, and maybe I'm mixing the two strategies again, so if you guys want to correct me on this, that's fine. But just with the wind, right? And again, they put that in the table under rate, which is fine. But you'd have the speed of the airplane. Now it's going with the wind. It's going with the wind, which means the wind is actually adding speed to the airplane. So I'd say x plus y, and then how fast did it go? Well, that's where we get the 120 right there. All right. And again, this is the rate of speed for the airplane, at least with the wind. But then against the wind, you got the speed of the airplane. It's going to go no matter what, but you'd subtract the speed of the wind from the airplane, which would give us its final speed, or average speed in this case, which would have been 80. And that sets up the system for us, which I think this one looks pretty good. And now we're ready to, because the coefficients of y's are opposite, we're ready to add these two equations together to eliminate the y's. So that's 1x plus 1x, that's 2x. That'd be 2 airplane speeds would be the same as 120 plus 80, that's 200 miles per hour. So if you doubled the airplane speed, you get 200 miles per hour. We don't want double, we just want one individual airplane speed. So 200 divided by 2, that's x equals 100. And again, x is the airplane speed, so that's 100 miles per hour. That's my airplane speed. Kind of added space there, so speed is SP right there. Well, if the airplane is going 100 miles per hour, just go to one of the two equations. Doesn't matter which one. Again, I'm going to choose the one that has a coefficient of y that's positive, just to make that easy. X plus y equals 120. That was with the wind. But now I know the speed of the airplane, which is x, is going to be 100. And yes, you could have just taken 120 minus 100. It's not necessary that you use the equation on this, but do subtract 100 either way. and then we get y equals 20, or 20 miles per hour. That's my wind speed. Bam. And again, we should be able to check, right? If the airplane speed is 100 miles per hour, just add 20 miles per hour to that, which was the wind speed, and you should get 120, which it does. And subtracting it, right? You take 100 miles per hour against the wind, you'd subtract that speed, the 20 miles per hour, to get 80, and that one checks off as well. So, and there is, I mean, with word problems, there's always this, at least a slight assumption that we've written the two equations correct. And again, I've seen this on the reality check for this module, where, you know, the work is great. It's phenomenal. There's no mistakes in the work. It's just that the one or more of the equations was written in incorrectly. So you know, make sure it kind of, I don't know, corresponds with the information that was given in the problem.